Okay, welcome to Strong Tree Academy, problem 23 review packet. So here we're asked to write the following series in sigma notation. Just maybe as a point of review, let's recall that series means we're adding stuff up. And you can see that it's what we're doing here. I guess to first start this out, what we're thinking about here is that let's just maybe write what's going on here. A1 plus A2 plus A3 dot 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 dot. And it's not immediately apparent what the last term of this series, or how many terms in this series there are, but you can kind of see here that it's going 2, 4, 6, 8, so we're counting by 2's up to 100. And so we could maybe deduce here that that's what's going on is 50. More complicated problems, you may not quite see it so easily, but that's something you always want to do in these problems when you're finding the series in sigma notation, is get a handle on how many terms there are. So here we can see that there's 50. I guess to start off here, I'd like to forget the fact that there's negative signs bouncing through there. Let's just see if we were going to write this in sigma notation for this series, what would we do? The way I like to do these problems is to write the term number above the actual term. So we know that this is the first term, the second term, third term, fourth term, fifth term, sixth term, etc. And then our goal here is, can we write this number as a function of that number? So, because remember, when we're doing the sigma notation, we're going to write something like n equals, and since we know we're going from 50 here, we're going to go from 1 to 50. Well, what are we plugging in? We're plugging in the term number into some expression that's going to give us the term. So that's why we're thinking of it this way, right? If we're going to write this, it's a sub n. N is what we're plugging in, and we need to get the term number. Oops, sorry about that, 50. Okay, so this one is relatively straightforward. We can see here that each term is just 2 times the term number. So like this second term here, I'm just going to put in 2, multiply by 2, get 4. Like for example, in this fourth term, I'm going to put in 4, get 8. So we've kind of found a big piece of it here, 2n. Right? If I went ahead and did that, I'd get 2 times 1 plus 2 times 2 plus 2 times 3 dot 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 plus 2 times 50. And that looks an awful lot like that. What we haven't taken into account here yet, though, is the fact that we have these alternating negative signs. So let's think about what we would do there. So again, what I've written here is the sequence assuming no negative signs. So all we have to do is really put a term in here. Sorry, that's a 1 to 50. That's going to alternate based on whatever n is. So we're going to multiply this term by n, and the trick we use here is we're going to raise, erase that, sorry about that. The trick is we're going to multiply it by 1 raised to a power of based on n. And so in this case, we can just go ahead and raise it to the nth power, because when n is 1, this will be positive. Oop, that's not going to work here actually. Negative, right? If we put 1 in there, it's going to be positive. So we have to multiply this by -1. There we go. Sorry about that. Yeah, -1. So when n is 1, this will be a negative number. When n is 2, or any even number, -1 will cancel out to become a positive number, and this would be then the final answer. But when you have these alternating negative signs, I do find it helpful to, what would you do before you even take out the fact that they're negative, figure out the answer, and then go ahead and put this alternating term kind of thing here, which again, sorry about the confusion, would always be like a -1 raised to one of these powers, or maybe it would be +1 if it started out with a positive term here. You'd have to put a +1 instead of just n. Problem 24. This is a relatively straightforward problem. Again, this is maybe just making sure we get the notation down. Remember, capital S of n means the sum of the first n terms, and that's what we're showing here: 1 plus 3 plus 5 plus 7 plus dot 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 plus a to the n. So we're using a sub n here as the nth term, and we're actually telling a formula for the sum of the terms. That's what n squared is. That means S of n is the sum of, sorry, n squared is the sum of the first n terms. Instead of, normally we think about giving it a formula for the term itself. Here we have a formula for the sum. So the first thing here is asks to find what s of n minus s of n minus 1 is. Well, that's a pretty straightforward algebraic exercise here. We're just going to write that out. S of n, we have the formula for it. We know it's n squared. And then s of n minus 1, well, we still have the formula for it, but in this case it's going to be n minus 1 squared. And then we just can knock out the simple algebra here, n squared minus 2n plus 1. Make sure to distribute that negative sign over everything. My son has issues with that. Plus 2n minus 1. We got these n squareds that canceled, and we have 2n minus 1 is what this difference equals. So now the meaning behind what we just did there is, well, what does this expression represent? Well, let's just write some terms out here and think about what that means. S of n minus 1 is going to be 1 plus 3 plus 5 plus 7 plus dot 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 plus a n minus 1. That's going to be the nth minus 1 term. S of n, actually we put this s of n up here, it's going to be 1 plus 3 plus 5 plus 7 plus dot dot dot. That nth minus 1 term is going to be there, but also there's going to be the nth term there. And now when we go ahead and subtract these guys, you can just see that that's going to cancel, 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 and all you're left with is the nth term. So s of n minus s of n minus 1 is just gives you the nth term in the sequence. We went through that a few times in class, but hopefully this visual here, when you see all these terms just knocking out when you do the subtraction, kind of helps cement why that's the case. So we were given a formula for the sum. We could use it to find a formula for a sub n. So like that would be another way to, if I had asked you what the nth term was, you'd say a sub n is 2n minus 1. And you could also recognize that as a arithmetic sequence, just as an FYI. Okay, number 25. Kind of a scary looking problem. We did this at the very end of the sequences in series where we talked about this idea of interval of convergence. I think it threw a number of people, but hopefully we'll see that it's not nearly as bad as we think. So the first part of this problem is pretty straightforward. Write out the first 4 terms of the sequence. Well, one thing is to make sure, let's look at what the counter starts at here. And remember, sigma notation always counts up by 1, but what we're going to do is just plug in n equals 0 for the first term. So the first term is going to be 3 over 2x raised to the 0 power. The next term will be 3 over 2x raised to the first power, 3 over 2x raised to the second power, 3 over 2x raised to the third power. If we wanted to go ahead and simplify that just to see what's going on here, well, anything to the 0 power is going to be 1. This is just 3 over 2x. That's going to be 9 over 4x squared. And then this last one will be 27 over 8x cubed. So that's part A. We've written out the first 4 terms. Hopefully you recognize this as geometric. You know, we're multiplying all these terms by a common ratio. But in this problem here, I actually told you it was geometric. So what is R? Let's go, you might just be able to see R as 3 over 2x, but let's just, as a little review exercise, how could we do that? Well, if you know a series is geometric, I could take any 2 terms, let's take a sub 2 and a sub 3 and divide them to get what R would be. So R would be a sub 3, a sub 3 over a sub 2. A sub 3 is 9 over 4x squared. A sub 2 is 3 over 2x. And if you simplify this, that's going to be 9 over 4x squared times 2x over 3. You can see that's going to be a 3 there. That goes away. That goes away. That goes away. You're left with 2x. equals 3 over 2x. So that would, this was maybe a little unnecessary for this problem, but just as a review item, that would be another way we could have found r in a geometric series. Then the last question here is interval of convergence and the sum. Well, interval of convergence, I've just actually told you what that, reminded you what that was, and I did that on the test this year too. It's the range of x values for which the series above will converge to a real number. So again, let's just think about what this is saying here. This is an infinite geometric series. Right, and what has to be true for an infinite geometric series to converge? Well, its common ratio has to be less than or equal to 1, or the absolute value, it can be negative, has to be less than or equal to 1. Those terms have to get smaller and smaller and smaller, otherwise that doesn't work. So we know that that's the condition, and then, so we have what r is here, so we just have that the absolute value of 3 over 2x is less than 1. Now, absolute value equations like this one are actually a little bit tricky to solve when you have x in the denominator, but let's think about what we would do here. If this expression is, absolute value of this expression is less than 1, that's going to mean it's going to lie between negative 1 and 1. That part is pretty straightforward. And we could multiply both sides by 2/3 kind of to get the x by itself here. So we're going to we'd get to negative 2/3 is less than 1 over x is less than 2/3. All I did was multiply everything here to get the kind of this x term by itself. Now here's where we have to do a little bit of interpretation. What does it mean if the reciprocal of x lies between negative 2/3 and 3/2? Well, that's going to mean that x can be greater than 3/2, or x can be less than negative 3/2. You have to think through why this is a little bit, but let's just do a couple sample cases here. Like if x is a really big number, let's call it 300. Well, we could easily see here that when we put 300 in here, 3 over a big number is going to be less than 1. If x was negative 300, same thing. It's a negative this time. So it seems like this is family of solutions here is kind of in the right ballpark, and we can see why 3/2 is kind of a break point here. If we put 3/2 into that expression, like 3 over, if we let x be 3/2, the absolute value of that guy is 3. Those are just going to cancel. Well, that's going to be 1, which is kind of the same break point here. So it's, again, this seems to make sense here that 3/2 is a break point, and if the reciprocal is going to be squeezed in here between these two numbers, that means that the original number has to be kind of outside that range and reciprocate it. So hopefully that's clear. That's, again, maybe a little more complicated than I might even ask you to do, at least that part of it. But this again is the x values, the expression that needs to be met in order for the x values for this sum to converge. And then the last question of this problem, maybe I'll call it part D, is to figure out a formula for the actual sum. Well, we know this is a geometric series. The sum of a geometric series is going to be the first term over 1 minus r. We go back up and look at our first term. Well, our first term is 1, so that part's pretty straightforward. And then r, well, we've already computed that too. We have the pieces we need. It's 3 over 2x. So it's 1 minus 3 over 2x. If we wanted to simplify that a little bit, we could multiply the top and the bottom by 2x here. And we get 2x in the top, 2x, distribute that, 2x minus 3. Either of these would be fine. You could either use that expression there, or I'll call it that one right there. But again, this value for the sum, the infinite sum, only works for that range. So you'd have to, that was the whole reason for the interval of convergence here, is that you'd have to say, well, that's the formula, but it only works when x is greater than 3/2 or x is less than negative 3/2, because if it's not, then this criteria is invalidated, or is not valid, and therefore this formula for the infinite sum just doesn't exist.